Everyone to the Hello World Guide. This is another episode of the C++ Raycaster game series, and in this video we are going to combine the vertical and horizontal algorithms that we created in the last two videos and combine them into a single working raycasting algorithm. So in order to do that, I'm going to open up my terminal and we are going to go into the raycaster directory, and I'm going to open up renderer.cpp. So after opening up renderer.cpp here, let me go under full screen mode, and inside of here what we'll do is, you can see we've got all of this here. Now before we actually begin, there is a bit of a bug that we need to fix, and if I show you, actually no, that's wrong. No, quit. So we are going to run make here actually, and if I run make, you can see that I get my raycaster, and as we had in the last video, we are colliding with the vertical walls. And now this works, but if I move in the other direction, you can see that we are not colliding with this vertical wall, we are colliding with the other one. We are passing through one of these and then colliding with the other one, and it always happens like whenever I am looking left, we are colliding with only one vertical wall, and a similar problem also occurs with horizontal walls. We do not collide if you're looking down, something of that sort happens. So in order to fix that, the reason for that is because of like floating point calculation error. So in order to fix that, it's pretty simple. When we inside of this, we are adding when we are looking right, and that is working. However, this is not really working, so we'll just subtract a really small value like 0.01 from this, and that should actually make it work correctly. And similarly, we'll do like in here, we'll also subtract 0.01 from this. So let me run that, and you can see that now that does work, and I collide with this wall and I collide with that wall too, and it all occurs correctly. And to show you the horizontal ones, I'm going to actually basically, let me just copy this. So I'm going to go ahead here and copy that, cut this from here, and we are going to go down here and paste this like that, and then we're going to remove this return statement from here, and yeah, let's go ahead and try actually running that. So let's first of all, let's run this without the subtraction so that you can kind of see the difference. So I'm going to run it like that, and remember we are using std floor here, not round. And if I do that, you can see that we are working on this hand, and if I look up, we are working on this one too. So it's now detecting both sides correctly, and the horizontal one is working correctly as well. Now we just need to choose one of these and use that. So in order to do this, how are we gonna go about that? Well, it's pretty simple, but the problem is that we basically need to draw the shorter wall. So we need to basically take the shorter ray, and we need to draw the shorter one. If the vertical one is shorter, we are gonna draw that, and if the horizontal one is shorter, we are gonna draw that. So in order to do that, we are going to do a couple of things. Firstly, you can see that well, we are returning here, we are not supposed to return here, and we are supposed to just skip the horizontal or the vertical wall check respectively. For this, I will create two variables called vduf for vertical depth of field, and we are going to set that to 0, and hduf for horizontal depth of field, and that's going to be 0 as well, similar to how we were doing the v10 and h10 here. So yeah, basically similar to that. So afterwards, the next thing we'll do is that we'll go here, and inside of this loop, we are not going to use I here. Instead, we are going to use vertical depth of field. We are going to increase vertical depth of field, and by default, remember it was 0. We are going to check if it's less, and we are going to leave the initialization completely empty. Now inside of here, instead of returning, we are just gonna take our vertical depth of field and set it equal to max raycast depth, and this will mean that this code will not execute, because it will already be greater than max raycast depth, equal to max raycast depth. So it won't execute this loop at all. So we won't be wasting anything. And in here, we are gonna do a similar thing, except that we are gonna set our horizontal depth of field, and we are going to say horizontal depth of field here, and yeah, let's use that. We are going to remove the I variable, and when we are doing this plus plus, we are going to use hduf as well. So yeah, that's gonna be pretty awesome. And the next thing we'll need to do is we need to calculate the actual distance between these 2 points. So for that, we'll go here and we'll create a float which we'll call h distance. let's call it edge dist, and we are gonna set this to s, and remember we are using the shorter distance, so by default we need to make it as large as possible. So we will set it to std colon colon max. So we'll set that to std colon max. Of course we'll need to, it's a templated thing, so we'll need to pass float, and we are gonna vdist, create vdist here, and yeah, we are gonna create this, and we are gonna set that to max as well, and we are gonna of course use float here as the actual argument type. This is hdist, and this actually needs to be vertical distance. Well, it still seems to give some problems. Oh, actually, that's a bit of a problem. We need to use std colon colon numeric limits. I forgot that part. So we are gonna use std colon colon numeric limits float colon colon max, and we can do this. So yeah, we can have that, and for hdist, let's just do that separately because it's a bit large. So we are gonna set our hdist similarly here, but we are gonna use of course std colon colon numeric limits like that, and let's just call max here, so max. Yeah, let's save that, and this will give us, set it to basically almost infinity, and that would work. We can remove this, and yeah, these two are representing our distances, and now when we hit the wall we need to just calculate the actual distance that we have got. So for calculating the distance we can just use the Pythagoras theorem. We are going to take our vdist because we are doing the vertical check here, and we are going to just go here and set our v distance to, well, we need to calculate the distance between our ray position and the player position. So in order to do that we will take our ray pos dot x minus our player dot x, player player dot position dot x actually, and we'll multiply this by our ray pos dot x minus our player dot position dot x, because we are essentially taking the square root, and then we'll go ahead and add to this our ray position dot y minus our player dot position dot y, and we'll multiply this by the same value, our ray position dot y multiplied by minus our player dot position dot y. And of course this alone is not enough, we need to take the square root of this, so we'll go here and call std colon colon square root on this, like that, that one. So with that, this should this should essentially do this for us. So it should calculate the vertical distance in a correct way. So we are gonna go here, copy this, and go down here, and we are gonna basically paste this here. So let's go here and paste this, and except we are gonna change this to h distance. So we have got all of this implemented, but the next thing we'll need to do, which is the most important one, is that we'll need to change our ray position, because currently we are using the same variable for our ray positions, which will cause some problems. So we'll have to create two separate variables. One I'll just call vertical ray position, and another one I'll call just horizontal ray position. So we can just call it v rays position, because why not. And we'll have these separate so that we can use them better. So I've gone ahead and quickly changed all of the actual references where we were using ray position to the x or dot y. We are changed that to use vertical ray position and horizontal ray position respectively in their icon parts. And with that, the only thing that's left is the actual drawing of line. So in order to do that, before we draw this, we are gonna check, we're gonna call vertex here, but we are gonna check if our h distance is less than our v distance. If that's the case, we are gonna use the h ray position, or else we are gonna use the v ray position. So we'll do this, and now let's go ahead and run this. And what you can see is that now we have got essentially a perfectly working raycaster. So this is a ray that we are casting here, and this ray is basically, well, it's colliding against the walls correctly, and it's wherever we hit, it collides against the walls in a perfectly good way, and it works both with vertical and horizontal, and wherever we look, it's stopping whenever it hits a wall. So that means that our raycasting algorithm is finally finished. So yeah guys, this is pretty much it for this video. I'll see you in the next one, in which we'll instead of casting just one ray, we'll cast multiple rays and kind of create a view cone for the player, and then we could begin the process of actual 3D rendering. So yeah guys, that's going to be pretty awesome. Stay tuned for that. I'll see you in the next one. Make sure to like and subscribe as well, and share this video with other people, and bye.